Hello and welcome back to Mr. Powers Teaches Algebra. So last time we talked about slope. We've been talking about lines, and now I kind of want to talk to you about the slope-intercept form of a line. And what is that? Slope-intercept form. Slope-intercept form. That's going to be y equals mx plus b, where m is our slope, which means m is the rise over the run, and b is our y-intercept. In other words, our y-intercept would be 0, comma, b. Because remember what a y-intercept is, something I haven't reviewed, but a y-intercept, it means graphically, well, it means x equals 0. Is where we cross our y-axis. Our y-axis is x equals 0. It's the line x equals 0. So, likewise, since we're on topic, x-intercept, this is a little separate, but the x-intercept is always where y equals 0, because it will cross the x-axis when y equals 0. Okay, so now that we got that out of the way, that's the general gist of it. I guess I'm going to do this out of order, but generally the idea here is you start with your b here. Okay, so we got a point, 0, comma b, and then we have a slope. So then we'd do our slope. We would count our rise and then our run, and we get another point. So once we know our intercept, we go up for our rise, we go over for our run, or down and over, depending if it's negative or positive. And then we would have our another point on our line. Once we have 2 points, we can graph it, and we know what we got. Okay, so that's the idea. So I don't know. I always have trouble like just leaving it there. So I was thinking of doing a little bit more. Let's say, if I really want to prove it, like there's different ways to think about it. Let's say I did have a point, a y-intercept, 0b. Here's my x-axis. Here's my y-axis right here. And we have a rise and we have a run. And let's say we got a line, okay, going through there, right? So we got a line. Oh, okay. We have a line going through there, so we have our y-intercept. And so can we describe any other point on that line? Let's say I got another point, and that point is x, comma, y. What is the equation of this line? In other words, I want to be able to take this, a very general case, and be able to get y equals mx plus b. Can I do it? And I can. So we know we can have a rise over run here. And we know what the rise over run would be. This point here has the same x as this one, so it's 0, and the same y as this one, y. So I know my rise. I know my rise here. The rise is going to be y minus b, because it's the difference in my y values. Y minus b is this distance. It's my rise. And my run, well, it started at 0 and goes to x. X minus 0, this distance is the same as just x. Okay? So what I could do is, and we are making the claim that m is our slope. Okay? So since our m, I'll do the math over here, is our rise over our run, then we would have m is the same as, what's the rise? It's y minus b. And what's my run? It's x. Now what would happen if I solve for y? And that's something that you want to notice also. When we have it in this form, in our slope-intercept form, which I was lazy and I didn't want to write it, but slope-intercept form, what you'll notice is that it's always y equals. We have y by itself here. That's what is always true in slope-intercept form. So what if I were to get this y by itself? Okay, so I multiply both sides by x, and I'd end up with mx, m times x, equals y minus b. And then I would have to add b to both sides. And what do I get? Y is by itself. Y equals, and on the left side here, it would be mx plus b. Well, there you go. So, hopefully that's a good explanation, and that makes sense why this is our slope-intercept form. Now, I'm just going to show you guys a quick example with a graph. So let's take a graph, a graphing calculator, and I'm thinking, let's graph y equals 3/5 x plus 2, just for fun. And so if we do that, if we were going to do that by hand, we would say, okay, well, plus 2. This is my y-intercept. And another way to think about that is, right, if x equals 0, because every value on our y-axis here, right, here's our y, here's our x-axis. If you think about it, you pick any point on the y-axis, all the points have an x is 0, right? So right here, I have my 0, 2. If you plug in 0 for x, you get y equals 2. And that would be my y. This is my x. This is my y, right? You plug in 0 for x, y is 2. It makes this a true statement. So that's another reason why when it's written like this, we immediately know this 2 is our y-intercept. It's this point right here. And now to find another point, I just need to go up 3, 1, 2, 3, and over 5. 1, 2, 3, 4, 5. And we'd have something like this. Of course, I'm eyeballing it here, but we'll take a look at a graph right after this. And I should have another point, right? So what is that? I had to go up 3, so I went up 3. So this should be, this 2 goes up 3. That should be 5 up now. And I started at 0 and I went over 5. So that should be 5 now. Up 3 over 5. That should be 5, 5. And then I have a line just like this. And if I was sketching it by hand, that's literally what I would do. That's as good as it gets. If I was doing a graphing calculator, it would look like this. Hold on. All right, so in GeoGebra, that's what I'm going to use. I can just type in y equals 3/5 x plus 2. And it'll show me some points. And I can also, let me see here, I think I can get a table of values. So we can throw some table of values here. Ending value for x, let's go 10. And we'll go, okay. So I got this table of values. Let's see, 5, 5 is a point. It is right there. There we go. 2, 0 is a point. So I go up 3 over 5. And I can go up 3 and over 5 again and find another point, 10, 8, and so on. So, yeah, worked out really, really well. I'm going to go back here. If I change it, if I can make it negative, that's going to make it go down now. So now it would be down 3 over 5. I got another point, right? And so that's another thing, too, to notice is our slope affects whether or not our graph is going higher or lower as we move left. So now I have a negative slope. My slope is negative 3/5, and it's going down from left to right. Okay? So there is another quick video on our slope-intercept form. I hope you guys found this useful and enlightening. And until next time, enjoy doing math.